Good, so we are looking at vertical projection. If you throw something up, you understand? This is as opposed to normal motion that I told you of, rectilinear motion, you understand? Here we're talking about vertical projection. When you throw a stone, so let's say you're on the floor, this is the floor, the plane of projection. Then you throw a stone up. When you throw this stone up, you give it an initial velocity, isn't it? The initial speed that you throw it up with. It will move up until it gets to a height. Like when you throw a stone up, will it continue moving up? It gets to a height. That height is known as X max, maximum height it can go. Once it reaches there, it gets to a final velocity of 0. Because at that velocity, at that height, it cannot move up again, isn't it? The velocity becomes what? 0 before it starts what? Falling down. Is that clear? So you have initial velocity u, final velocity v is equal to what? 0. At maximum height, final velocity is 0. This is not the velocity that you used to get in here. But the velocity at maximum height is always what? 0. And you know the equation of motion, isn't it? This is the normal equation of motion. Once the body is moving up, it is being drawn down by the acceleration due to what? Is that clear? And I told you that for a motion of an object up, it is negative or positive? Negative. Because the force of acceleration is down. So that motion is opposite the normal force of acceleration due to gravity. So it's negative. So we have v is equal to u minus dt. This is the first equation of motion, isn't it? Now, we know that at maximum height, what is v? 0. Isn't it? So we want to make t the subject. So you have to bring this is minus gt. Coming over will be plus dt, isn't it? Make t the subject of the formula. We have t to be equal to u over what? G. So this is known as time of flight. This is known as what? Time of flight. So what is time of flight? What is time of flight? The time taking the object from the point of projection to the what? Maximum height. Is that clear? That is the time of flight. But what is the total time? What is the total time? If the time of flight is the time for the body to get from here to here, total time will be 2 times, is it not? Because total time of flight will be total time of the whole project of the whole motion will be from here to here, then from here to here. That is 2 times from here to here, is it not? So total time now, this total time is equal to 2 times t. Total time is the time of flight, time of the whole thing. But time to get to the maximum height is what? Small t. No, this is a mistake. Time to get to maximum height is small t, isn't it? But the total time of the whole thing will be 2 times time to get to the maximum height, which is t, time of flight, equal to 2 times time to get to maximum height, isn't it? But you know that small t is already u over t. So 2t will be 2u over t, isn't it? Now, how do we get the maximum height? We use the second equation of motion. And that second equation of motion says that what? V squared is equal to what? U squared what? Minus 2as. Huh? But if it is vertical motion, we call it head maximum. And this a changes to what? G, isn't it? This is actually the third equation, right? So how can you calculate head max? We know that at the maximum height, velocity is what? 0. So we have 0 is equal to u squared. That is this one. I've already written it here. This is the equation. 0 is equal to u squared minus 2g h max, isn't it? Now, since here is 0, you make this the subject, you have to carry it over here. 2g x max equal to u squared. So x max is equal to u squared all over what? 2g. Can you see that? So that's the maximum height. So whenever you're talking about body that is under vertical projection, the time taken to get to maximum height is simply equal to initial velocity over acceleration due to gravity. Is that clear? Whereas the maximum height is simply gotten from what? Initial velocity squared over what? 2 times acceleration due to gravity. Is that clear? So that is for vertical projection. Now we are going to look at horizontal projection. We are going to look at what? Horizontal. Horizontal projection. What happens in horizontal projection? Now when you're talking about horizontal projection, you talk about a motion that has this form, this trajectory form. Is that clear? You have height. So you throw something like a coin. Let's say this is a tabletop. Tabletop. You release something like a coin from here. It makes this motion. This is known as what we call horizontal range. So you throw a coin. So this kind of motion goes in what we call a parabolic path. This is known as a parabolic path. It takes some time to reach the ground as though it is dropped vertically from the same height. It takes longer time. If you have dropped this coin straight down, it will take shorter time than when you drop it like this. Is that clear? It takes longer time to drop. So for this very motion, height from projection, h. We want to calculate the height from projection, h. This height, is it not? Height from projection. How can you calculate this? You can get it by using ut plus half gt squared, is it not? ut plus half gt squared. This is the motion for under gravity, is it not? This is normal equation of motion. You will now use h in place of what? S. And g in place of what? A. Isn't it? So this is normal equation of gravity. Now, this is what we have to calculate the height. What is the initial velocity? Before this thing starts moving, what the initial velocity will be what? 0, is it not? At this point, velocity will be what? 0, because it has not started moving back. So if you get this to be 0, this equation will be what? H is equal to 0 times t will be what? 0. So it just be half gt squared. H equal to half gt squared. Is that clear? So make t the subject of the formula. What be the time? T will be equal to what? How can you make t the subject of that formula? Root 2h over, it will be what? Root 2h over g. I hope you know how that happens. If you have h equal to half gt squared, this is what you have, huh? So this is the same thing as saying h equal to gt squared over 2. Is it not? If you cross multiply, you have gt squared equals to 2h. Is it not? Make t the subject. T is equal to 2h all over what? G. G squared is equal to 2h over G, isn't it? Make t only the subject. T equal to root of 2h over G. So that's how you got this. Is that clear? So t, that's how you can calculate the time. Check it. To get to the ground. Is that clear? Is that clear? So how do we calculate the range? Range is this distance, isn't it? How can we calculate the range? You can also use the same formula. You can use the formula of you can use the same formula. Range is also distance, isn't it? So we can use the placing our root to be equal to ut plus half what? Gt squared, isn't it? You can use our head in place of that. So if we have that, but we know that at the point here there is nothing like gravity, because it's already on the floor. So the effect of this will be 0. So we'll be having r equal to ut plus 0. Is that clear? R equal to ut plus 0. So in any case, you can now say that r is equal to ut, isn't it? Now we can now say that r is equal to, what is u? U is u. What is t? T is what? Root 2h over g. Is that correct? Is that correct? So that's what we have for horizontal projection. So for every horizontal projection, h is equal to half gt squared and t is equal to root of 2h over g. Whereas for vertical, for the range is equal to u root 2h over g.